Okay, let's continue with the next steps. First, we need to create a projectile here, right? This projectile should be one that inherits from actor. Okay, we can take a shortcut and not open the editor. We'll just create it this way. We add this. It should be an actor, right? This part should change. Actor, we inherit from actor, and the name will be xjnetdemo, and it's called projectile. This is our projectile. Okay, after we create the projectile, it looks like this. Obviously, this project, it probably hasn't refreshed. I think it hasn't refreshed. Let's refresh it. Oh, it refreshes itself. That's pretty good. We haven't implemented refreshing yet. Okay, between refresh. And first, let's make sure our compilation passes. Then we'll continue with everyone to write this projectile. Good. Compilation passes, and this is our projectile. First, we'll add some components we need to use here. Okay, you'll notice it's written as public here. Sometimes we use protected or some red data to allow private access and such. These are all small details, no need to worry. Then here, we'll give it a collision box because we use a forward declaration. A forward declaration avoids including header files because if you include other classes here, it doesn't know what this thing is, so you need to forward declare it. We just need to include it in the original file. Then the first one is the collision box. The second one is used for world alignment. This is the static mesh, and this is for the projectile. Such a component. It is essentially equivalent to a movement component, but it's a movement component for moving this kind of object. Then here, we need to prepare a particle to play a particle effect. And here we need to specify the damage type. That is, what kind of damage it might be. And finally, our projectile. What kind of damage it will cause. So that's what these things are for. Okay, compiling like this should be fine. Okay, let's wait for it to finish compiling because I need to make sure everyone is correct at every step. Okay, we can basically just copy this from the document. Actually, this part is simple. Just include these header files. Include them. This should be no problem. They should be very familiar to everyone. We've already written nearly 20,000 to 30,000 lines of code. By now, there shouldn't be any issues, right? Then, after the inclusion is done, we'll proceed in the constructor function. First of all, let's open this copy. Because our motion actor is not replicated, this tick is enabled. If it likes being on, let's keep it on. Because we are not yet at the stage of optimizing each actor's tick cost. So let's proceed in order. First, we create this sphere box. So this sphere box is created via create default subobject. Then we initialize it with an initialization. Then we file it. It's this collision. We change it to all the main ones. Such a collision. That is, we often change collisions, and I often turn off all the collisions of that static mesh. Right. We directly use collision boxes to replace them. Then we specify that node. We use this collision box. Go to the root node. Then next, we will continue writing our replacement mesh. As for size mesh, first of all, we definitely need to find the mesh resource we want to use. It is found through this consult helper method. Of course, we can also specify it through blueprint. This path is fine because this path is the one for finding the starter content package. So it's fine. Then we attach it to the root node. Then here, this resource of ours might not be found. This resource will fail. So here if this resource succeeds, base consult. After the FGF finder finds it, then we take the static mesh, which is our static mesh component. Set it as the static mesh and adjust its relative position. This should be fine, right? Okay, next we have the particle system. Similarly, we find this particle in the mat package. Then after finding it and completing it, if it succeeds, we take the support. This place, we take this particle. Just point it directly to this particle system. Okay, so next, we will create our projectile component. We've already created it, at least for the third time now. Everyone should be on at least the third time. There's nothing much to say about these things. This one of mine has a bit of a feature. Close to be neutral. This places rotation. Rotate following the speed. This is one of its names. Look at that side. After the sales rim is done, then here we are. We need to specify this should be tab class because we haven't defined it yet. This damage type. So we just let it pass a default one. This section is placed wrong. Then here we handle main grants damage. Get it done. Make it 10 o'clock. Okay. So then our constructor is basically done. Okay. Then here we need to overwrite this destroy method. Let's put it above here because this method, we will call this destroy. When destroying, we need to do something, that is, when this object is destroyed, we need to trigger this spark, right? So first of all, we need to find the position of our player. Get the position, not the player's position. It's our projectile. Now at this position, then we directly through Jinta, not to Jinta function library, because it's a particle. It's not a Niagara particle. It's a particle. So this is a particle. I see directly through the Gasma static, because the particle example is an old UE5 style example. Then here we just pick something and pass some default parameters for this thing. There's nothing much to say about this. Spawn an example. Everyone should spawn them often. Okay, so whenever this AX is destroyed, this function will be triggered. And the next, we need to prepare our function to perform such a binding. Event binding, right. So first we need to prepare the event to be bound. We'll put it in the particle. Also put it in the particle. Just put it here. Putting it here is fine too. Okay, these collision events, we probably don't need to explain them in detail. Why these function signatures look like this? Right, because it's obvious they were copied from our collision box. These function signatures, everyone should be very familiar with them. And when this collision happens, what is it supposed to do? First, as long as this actor exists, we can directly apply damage to it. Then we can destroy ourselves. Okay, here, this collision must occur on the server. Pay attention to this. This collision must occur on the server. So how does it do that? Because it only binds on the server. So it will definitely only occur on the server. Therefore, regarding apply damage here, we can take a look. Here's a gameplay of static apply damage. He just does it with take damage. You see, this place is mirror damage and then point damage. Normal damage, and then here, blah blah blah. A bunch of parameters are passed. Then just pass them directly. There's no problem here. Okay, and then this place. It will have some collision results and such. Because it's point collision. And then here, we come back. Come back here. We are here. We are dealing with collisions here. So we have some results here. We pass those results directly into it. And then because our instigator means we need to get who currently generated our projectile, get our instigator. Then there's a controller in here. So obviously this instigator, let's take a look. Obviously this place is CauSer is itself. It causes damage by itself. This damage type, this type is the one we use, the modern type. And then this ingester, it gets the characters, gets this controller. So this ingester should probably be the character. Yes, it depends on how you generate it yourself. When we generate it later, we will be able to see how this ingester is set up. Because we definitely need to spawn this thing. So this is after the collision. Then we transition up and down. Actually, we have been writing it backwards all along. Now we need to bind this method. To bind this method, we will write it in the constructor to perform the binding. We can write it at the very bottom. Then we first need to check. We can just write it here. We bind this method here. And we only bind this method on the server. So we can just bind it here. Okay, now let's compile it. It should be fine. Okay, you can see this is completely fine. No problem. Okay, then let's move on to the next part. First of all, we definitely need to bind a key. Because only when we press the key will we spawn this projectile. So we need to open the editor and grab a key. But you might not know yet where this ingester comes from. Actually, later when we spawn an actor, we will pass in some paths. Then you'll understand how it all connects. Then let's go to our input settings. In our input settings, we will add an action here, a mapping for establishing a position. Then if we give it a name, we give it fire. But we don't want to use the growing input. We just want to match our tutorial. This is a left mouse button. Okay, this is a left mouse button. Okay, after that, we close it. Then we go to our characters CPP file. First of all, in the CPP file, we definitely need to include the projectile first, because we will need to spawn this projectile later. And this projectile has this name because we changed the name. So here, then this projectile, you can define it freely. We have also emphasized this many times. So you can launch some things like ice and fire. We put this variable down below. Make it property related. Put it down below, and then here we first prepare a T subclass. This way you can change this projectile through blueprint. Of course, regarding this projectile here, check the name of this field declaration, otherwise the name won't match. And then next is our ignition. A delay in firing. This delay is because we don't want it to fire continuously. We want it to fire at a minimum of 0.5 seconds. So we need to create a timer to act as a switch that allows firing. This kind of design is quite common, and we should use timers sparingly. But in this case, only the player will have this issue, so it should be fine. This is just a boolean to make it easier for us to determine whether a projectile is currently being fired. Then we start preparing these functions. It's written this way here, so we'll leave it as is. So this is the function to start firing. Then this is equivalent to restoring its firing. That is, it's equivalent to resetting. Actually, it's called reset. Then, because our function must actually fire, this function must be executed on the server. We need to jump to the server via an RPC. So this is how it's done. Then this is a timer handle. Then we will use something like this later. So let's create them one by one first. Because now we are layering up and down. Our middle layer and the lower part are already written. We need to sort out how the upper part calls it. We only provided some variables here. So first, in the constructor, we need to initialize some variables. First, we replace this class with our. Replace it with our. The class we wrote ourselves. Our default, because we need a default object to have this U class. So we can proceed. Then we set this fire rate. Delay to 0.25 seconds. And by default, we are not firing. So this is a default initialization step. Then here, we start firing again. StartFire. We can see StartFire actually executes on our client side. This will be bound to our left mouse button. So, because you are on the client, we first determine whether you are currently firing. If you are currently in a 0.5 second cooldown period, then you cannot enter. Only after your cooldown is complete, and this is forced, can you enter when you click for the first time. It will definitely be forced. Then after we enter, first set this firing, set it to true. Then the next time you click, it won't take effect. Then we use getWorld, get our world to set this timer. The purpose of this timer is actually to make hits after about 0.25 seconds. Press reset. So this function StopFire, how should we write it? StopFire is actually after 0.5 seconds. We just need to reopen this variable. During this time, you can trigger it at most once. This way, after meeting our judgment, we just jumped onto the server. Jump to the server. This hand file cannot be written like this. If you write it like this, you'll find it won't compile. Yes, this is what we mentioned in class. Right here, if you get this error, this kind of error usually means it can't find the implementation of this function. Then we can, the implementation here. Okay, this method you should remember this implementation because it's a very special RPC function. The main thing is here. It ensures the effect of this RPC. It actually needs to be inside C1's house. Add an implementation. This way of writing should be very common. Okay, then by jumping to the server, this plate is the server. So what do? We need to spawn this actor. So how do we spawn it? First of all, we definitely need to find the current position, the position where we are currently spawning. So here we get the player's position and perform a calculation on the player's position. A simple three-dimensional vector calculation. We won't worry about this calculation. Anyway, it just went to find the location. It's just a small piece of gameplay knowledge. Never mind it. Then at this point, we get the player's rotation. And here we have some parameters. Okay, there will be some parameters here. As for these parameters, the first one is to take this, what is this called? Ingester. Here, get ingester, right? That is, we get the ingester. As for this pun, getting this ingester, you can see this ingester method. Actually, it is a method of this paradigm in actor.h. So in practice, it is actually in this. It will return this object. This object seems to be an instigator. This is in the actor. That is to say, it is the one responsible. That is who's responsible for this damage. This thing. Okay, then after getting it, it will get its controller. That is in our. We can jump back and take a look later. We can set a break. Take a look at whether it's this ingester. There will be a controller here. And this is actually the controller of pun. So it should get this ingested. Get the ingested of the. This place is a bit noisy. Anyway, in the end, it gets our player's controller. That is, to get this pun from this ingested, yes, it should get this object. Then get its controller. It should be like this. Okay, we can set a breakpoint and take another look. This doesn't affect anything. As for this owner, it is something that we all possess. This owner is very critical. This owner. But this owner can be set to null. However, we need to make it here. Just attach it to the character. Just have it possess it. This way, it can also have this owner only after joining this link. Can we do some synchronization related tasks? Then, with this parameter, we can directly here generate the productive here. This place does not use this syntax. It does not use this. The first letter of this is lowercase. Just ignore it, because the person who wrote this document might prefer this lowercase style. Then we take these prepared parameters, position, rotation, and the generation parameter. We just need to use gateway to spawn this actor. Because spawned actor has many forms. You can choose whichever writing style you like. Then, on the server, we generate such an object. So how is the firing done? After this object is generated, it will launch and collide. So how do we generate the firing? Actually, we bind it here. We are here. We won't worry about this part, because we are not using this incremental sketching system. We can just write it at the very bottom. We directly bind the action here. The most likely binding is our star file. This is one method, you can see. Okay, after binding this method, we are actually done. Now let's build it. Okay, in the next lesson, we will set a breakpoint and test it, because this is the first relatively complete effect. Once everyone understands this clearly, it will be convenient for everyone to migrate and reuse it later.